My name is Laura Marie Coleman. Thank you for joining me for this second part of the Addition and Subtraction Word Problem Situations video series. In our first part, we looked at add to and take from problem situations. Take a look at these two problems on the screen. What do you notice is different about the second problem about the bowl of fruit? You might have noticed that the first problem in an add to problem situation, we have some frogs in the pond and then we add more in. So not everything is there at the start of the story. In our put together, take apart problem situations that we're going to look at today, everything in the problem is present when the story starts. And we're either going to put together the parts of that set, or we're going to take that set apart. So today we're focusing on addition and subtraction word problem situations that involve put together or take apart. So we know we have all the objects at the start of the story. Again, we're going to be using the read, draw, write, or RDW approach for problem solving. We're going to read the whole problem to get the big picture. We'll go back through the story and represent one piece of information at a time in our drawing, and then we'll finally look at our picture, decide how to solve, and write an equation to represent the story. We're going to be looking at the middle row of this table from the progressions document, which is also found in the Common Core standards and many state standards. In this video, we're going to be looking at put together take apart problems, and there's three kinds of these. We might have the total unknown, both addends unknown, or one addend unknown. So let's get started. Here's our first problem. You already looked at it. There is a bowl of fruit on the table. There are 5 apples and 7 oranges. How many pieces of fruit are in the bowl? So we know from the start of this problem we have a bowl of fruit. We know we have 5 apples and 7 oranges. There's no adding to it or taking from it. They're all there in the bowl on the table together. The question is, how many pieces of fruit are in the bowl? So we really want to know what is the total. We know the parts that we have. We just need to add them together and find the total. Here's another one. This is an addend unknown problem. Tom has 20 stickers. 11 stickers are blue and the rest are yellow. How many yellow stickers does Tom have? So in this story, we know we have 20 stickers. They're all there on that piece of paper. We learned that 11 of those stickers are blue and the rest are yellow. We don't know how many are yellow. That's what the question is asking us to find out. So we're going to take Tom's 20 stickers. We're going to take them apart into the blue group and the yellow group, and we're going to find out the missing addend for how many stickers are yellow. So we could think 20 is equal to 11 plus however many stickers are yellow. Students also might think of this as 20, and if I take away all of the 11 stickers that are blue, the yellow ones will be left. There's lots of options for how students want to write an equation to represent some of these stories. Here's another one. Put together, take apart, both addends unknown. This is one that often trips us up as teachers because there really is no wrong answer as long as students have the right total. So Mrs. Smith's students made pictures in art class. Some students used crayons and some used markers. What are some ways their pictures might look? So in this situation, we know that there are 15 students and each one of them made a picture. Here's some examples of what those pictures might look like. I might have 10 in marker, 5 in crayon, 5 in marker, 10 in crayon, 9 in marker, 6 in crayon. The options are pretty much limitless. There's lots of ways students can decompose that 15. For my equations, I did 15 equals, and then my parts, 10 plus 5, 5 plus 10, or 9 plus 6. In summary, it's important to know that problem situations are based on the events of the story, the information provided, and what the question is asking, and that there's multiple types of problem situations for each operation. The concept that different problems you'd solve with the same operation have different types of stories and situations is what makes word problems so tricky. It's important to be able to identify each word problem situation for a couple reasons. We want to be able to identify the specific problem structures or situations that students are struggling with. We also need to be able to intentionally create word problems with that specific situation in mind, so we can provide them the practice that they need. Thanks for checking out this video, and I hope you'll visit our website, pimaedu.com, for more videos and resources. And also reach out to us if you're interested in some custom PD or instructional coaching for your school or district.